We have identified ways in which Hero can help in changing the here and now of operations in the hangar and in activities connected with it. The next step is to consider ways in which we can change our future. The world is full of good ideas. But somehow life often doesn't work out that way. And the reasons why it doesn't are of special interest to anybody considering achievable long-term change in aircraft maintenance. Some measures, especially those relating to hands-on activity, are relatively easy to implement and can show an immediate improvement. But what of the more complex issues affecting long-term decisions about the way the company is managed?
Let's step back for a minute and consider what all of these things mean for the total organization. Here's the kind of event we all want. Another uneventful flight is at an end. In half an hour, the aircraft will be on its way again, earning its keep, creating jobs, making a profit.
And we all recognize the importance of learning from mistakes which may be rare. But we tend to pay much less attention to learning from things that go right. Indeed, safety is just about the only thing we measure by its occasional absence. Why is this so?
Safety is a non-event. It means that there's been no accident, no incident, no bad happening on that particular day. And we make the assumption that if nothing is happening today, and we go on doing nothing, as we seem to have done today, then nothing will happen tomorrow. But that's entirely wrong. Safety is actually a dynamic non-event. We have to work very hard to make nothing happen. Consider the rubber band with a knot in the middle. Let's imagine that the knot represents the system, and that these ends represent the factors that control the system. Here we have the area in which the system operates. Down the middle, there is this narrow green zone, which is safety. On either side lie the hazards and the dangers. As the system moves through this space, there are disturbances. This might be time pressure, and we compensate for this disturbance. Here we might have commercial pressures, and again, we can compensate for it. As we go down this green zone, we're all the time making continuous, dynamic corrections in order to control the location of the system within the zone. The crucial point is that safety is a dynamic non-event.
Roger, just show me the connector that proved to be the problem, could you?
That was the normally closed solenoid. We replaced that on the rig during the final test.
Implicit in managing error is the need to balance one kind of risk against another. This is something we do all the time. Parents readily accept the risks of sending their children to school, because the risks of not doing so are much greater. No education, no opportunity to relate to other children, and a limited chance of developing as a whole person. Of course, we take reasonable steps to reduce the risks. The same holds true in our business. If we were to do all that it is possible to do, complications and collisions with reality would bring serious new dangers to the workplace. For example, it's impossible for rules to foresee every eventuality and for procedures to cover every combination of possibilities. Indeed, any set of rules attempting to achieve this would be unusable. We can never totally eliminate the possibility of error. Our aim must be to manage it. But how much effort, time and money can be justified? We must be realistic, working towards a level of risk that is ALARP, as low as reasonably practicable. Hero recognizes this. It is a strategic approach with many tactical elements. Think of error like a problem with mosquitoes. They can be attacked when they appear, and that may prevent people getting bitten some of the time. But to eliminate both the immediate risk and the long-term hazard of malaria, a systematic approach is called for. The breeding grounds of the insects need to be located and the problem dealt with at source. This will greatly reduce the risk, but may not be 100% successful. So other defences are needed. Mosquito nets, insect repellents, and preventative pills. Finally, if the worst does happen, we need a way of recovery, medicines to treat malaria. One well-proven tool which helps deal with these issues is the safety loop, the foundation of a number of widely used safety management systems. This helps apply hero principles used in the hangar to wider organizational questions. The first step is systematically to identify the hazards. Case by case, thinking the unthinkable. If the worst did happen, how badly could the hazard hurt us? It can be helpful to look at the wider world. In some kinds of industry, the things that can go wrong are clearly visible, and a minute-by-minute awareness of them is an important part of defense against disaster. In other kinds of business, merchant banking for example, the limits may be hidden, distant, and possibly ignored for some time without obvious or immediate ill effects.
Some months before the disastrous collapse of Barings Bank, the senior managers in London became aware of major imbalances in the accounts of their Singapore trading office. They decided to carry out an investigation, but as the group treasurer admitted at the inquiry, there was always something else more pressing to be done. And that seems to me to be an excellent epitaph for all organizational accidents. There was always something else more pressing to be done.
We face both kinds of hazard. Sometimes the limits to safe operation are immediately visible. In other places, they're hidden and distant. They may be the result of decisions taken long ago. And it's all too easy for seeking them out to be overtaken by something more pressing to do. An essential question to ask is, who is the accountable person? Hazard identification must be built on a clear understanding of who is responsible for what. This is, of course, in part common sense, but only in part. It demands that we ask questions we don't normally address, either because they're so familiar we take the answers for granted, or, on the other hand, because we haven't previously recognized some issues as presenting a hazard. When a hazard is identified, the next step is to assess the risks which it presents. How likely is it to cause us actual harm? The tools of risk assessment can range from sophisticated computer-based mathematical models to a simple score sheet. However, the most important tool is informed professional judgment. And one of the great advantages of this process is that it addresses this judgment to issues which might otherwise be overlooked. With hazards identified and risks assessed, it's possible to implement control measures knowing where valuable resources of time and money can be invested most cost-effectively. We know that this process, like everything else we do, will not be perfect. The unexpected can still happen, and things may still go wrong. So an important part of the safety loop is recovery, measures to mitigate the effects if, despite our best efforts, error still occurs. Finally, we need feedback, because without it, we'll have no way of being sure that our efforts are having a continued effect. The safety loop becomes a living system, rooted in reality, learning from experience, and responding to change. Let's take an example of how these principles might be applied to work on control surfaces not visible from the ground. In identifying hazards, it's essential not just to recall what has happened, but what could happen in the future. A hazard which may be identified is someone forgetting to replace fastenings. Of course, there are procedures to prevent this, and they may have been successful so far. But nevertheless, could such a thing happen? If such a thing is possible, how likely is it to actually happen, say, in a 5-year period? And if it did, what would the outcome be? Difficult questions, but ones which lend perspective. There are many ways of grading risk. Let's use the simplest. A scale from impossible to very likely on one axis, and from minor to severe on the other. Where the lines cross indicates what kind of action is appropriate. Most obviously, very unlikely events with minor consequences may not call for new action, whereas likely events with a severe outcome will demand careful examination. In this instance, suppose our assessment is that such an error over the time period is unlikely. Two facts face us. It could actually happen, and if it did, the result, if undetected, could be catastrophic. This means we must consider specific control measures. We know that operating procedures are in place. However, we have identified a risk of these defences being breached. We need to consider ways of reinforcing the procedures, to take account of possible forgetfulness, failure of communication, or incomplete documentation. Such measures will vary from place to place and call for professional judgment to achieve the best effect for any given input of resources. Controls of this kind will probably feature reminders that are highly visible and easy to use. Ways of storing components so they're not easily forgotten may also be valuable. Such measures, and the thinking that goes into them, and the awareness they create, will move the hazard further down the scale of likelihood. But even strengthened defences can be breached. So a means of recovery is needed in case error still occurs. This may involve double inspection or a total exterior check of all areas disturbed before the aircraft leaves the hangar. Resources are always scarce, and this process helps ensure that time and effort are focused where they will have the best effect. In the process of feedback, which completes the loop, we can see if the controls are working or if there are impediments to their use. We can discover if there have been lapses and whether we need to alter anything. Changing our future has its roots in understanding our past. And the most important raw material of error management is data in a form which provides maximum benefit from the experience of past errors. A widely used means of doing this is MEDA, Maintenance Error Decision Aid. This is a user-friendly, paper-based system which enables error patterns to be identified and provides the basis for remedial action. It's often helpful to look at the organisation as if visiting it for the first time. Do physical factors like lighting and access equipment need attention? Can work in progress be readily overviewed to be sure that it is on track and that procedures are being met? Are supervisors able to concentrate on supervision, or are they drawn frequently into other tasks? Do shift patterns and handovers take account of known tendencies to error? Is work in progress discussed in detail, and is adequate time allocated to it? Do we see the individual as a whole person, or just as someone who is there to perform a specific set of tasks? Is there training for new employees and to provide updates as equipment and technology change? How well balanced are commercial, scheduling and maintenance pressures? Interfaces between functions need to be checked out for potential misunderstandings. Learning from mistakes must become an enthusiastic process which engages the professional pride of everyone involved. HERO can be extended by the introduction of a computer-based system like MESH, Managing Engineering Safety Health, which uses an organization-wide system of questions and answers to draw upon the wisdom, experience, and professional opinions of people in safety-critical jobs in order to identify future error-provoking conditions and remove them before disaster can strike. BASIS, an information system devised by British Airways, is in use by many airlines to manage error data. GAIN, Global Analysis Information Network, is a new activity aimed at exchanging safety-critical information across national boundaries. So how different does the organisation need to be? Is there a need to learn more effectively from the past? Is there a way of removing the conditions which will cause future incidents? Is the working culture a barrier to advancement or an engine to drive beneficial change? Is there feedback to allow you to know that your goals are being reached? An increasing number of organisations are drawing all of these strands together into a formal company-wide safety management system, which covers flight operations, engineering maintenance, and ramp activity. At the start of this series, we set out a simple yet profoundly important choice. Either we manage human error, or human error will manage us. Whatever your response, the future begins now. The choice remains, and the decision is yours.